fractions. And so if you notice up here on the board, I have an example of what a partial fraction is. And so basically what a partial fraction is a partial fraction is saying that this right here equals this fraction right here. And so what's going to happen is we're going to start with this and we're going to get this. Okay, and so each fraction in the sum is called a partial fraction. So I have a partial fraction here and a partial fraction here. The sum of these partial fractions makes up the partial fraction decomposition of the original rational function. Okay, so basically we're going to decompose this big fraction here into component parts. Okay, it's not super hard as long as you follow the steps. So we're going to find the partial fraction decomposition of x plus 13 all over x squared minus x minus 20. The first thing you're going to do is you're going to factor that denominator. That is the very first step. What will that denominator factor to be? X minus 5, x plus 4. Okay, so that's my very first step, just kind of for my own information. And then now, what I'm going to do, okay, just a second, there we go, is I'm going to go ahead and write this as two partial fractions. So what I've done is split this up. A over x minus 5 plus b over x plus 4 will equal that. And what you actually could do, if you didn't want to have the x squared minus x minus 20, you could just put x minus 5, x plus 4 right here if you wanted to. So now I'm going to look at the fraction. What is my common denominator between all three of those fractions? What is the common denominator between all three of those fractions?
X minus 5 times x plus 4.
Perfect. Say that louder.
X minus 5 times x minus 4.
Okay, so x minus 5 times x plus 4. So what I'm going to do is I'm going to multiply each of these fractional parts by x minus 5 and x plus 4. So I'm going to multiply each of the parts by the common denominator. So now let's look at the first fraction. I've got this and this that are in common, right? So really that leaves me with a times x plus 4. What happens on the second one? Yep, b times x minus 5. Very good. And then what will that equal? Right, x plus 13, because these cancel. So now I'm going to distribute my a and my b. Okay, so distribute, distribute. So really I get ax plus 4a plus bx minus 5b equals x plus 13. Now this next step kind of gets a little funky. So what we're going to do is I'm going to look at the left side. Do I have any like terms? Would you agree that I have a like term here?
Yeah.
Okay. So really what ends up happening is I have ax plus bx. That is a like term. And then I also have 4a minus 5b. Now, I notice on this first one I can factor out an x, right? And that leaves me with a plus b. What? Yeah. Now, this is something that we did in algebra back when we were in the matrices chapter, okay? Because this is an x here, right? And this is an x here. What is my coefficient of x on the right side? Right here, coefficient. 1. So basically, I know that a plus b has to equal 1. So that's your first equation. Okay. Now likewise, I've got 13 here. And 13 has to equal this one, 4a minus 5b. Now there are two ways to solve this. Well, actually numerous ways. We could use elimination substitution. We could graph. We could use an inverse matrix. We could use Cramer's rule. Doesn't matter. We could probably whip through an inverse matrix fairly quick. So if we went ahead and did this, I would have 1, 1, 4, negative 5. And then I would have AB equals 113. So go ahead and enter the first one in matrix A, the second one in matrix B. Use your inverse matrix, A inverse B, and come up with the answer. What'd you come up with? 2, negative 1. So basically what that tells me is that A is 2 and B is negative 1. So I'm going to go ahead and write that out. So I'm going to use the one up here, this equation right here. So I've got 2 over x minus 5, okay, plus negative 1 over x plus 4. And there's your partial fraction decomposition.
Why did you put 2?
Because in this case it's a over x minus 5 plus b over x plus 4. Now we're going to look at one more since we've kind of gotten the hang of things. And there you go. So find the partial fraction decomposition of 2x plus 5 over x squared minus x minus 2. Now this one should go a little bit faster because we've already went through one. First thing to do is factor. What do you get?
X plus 1, x minus 2.
Okay, x plus 1. I think I did x minus 2, x plus 1 first. So x minus 2, x plus 1. And so now I'm going to go ahead and write that out. A over x minus 2 plus b over x plus 1 equals 2x plus 5.
You have to go with negative 2 and
No, that's just how I did that when I did the equation in here. You could do it the other way. You'll just get your answers reversed from what we do on the board. So now the next step, if you remember, was to multiply by the least common denominator. So the least common denominator will be what, folks?
X minus 2 times x plus 1.
X minus 2 times x plus 1. Now you might be noticing a shortcut here, and the shortcut is that you just attach the denominator that it's not. Okay? If that made any sense to you. So I'm going to cancel out the x minus 2's, and I get a times x plus 1 plus b times x minus 2, and that's going to equal 2x plus 5. Do you remember what we do now? Yep, distribute. So ax plus a plus bx minus 2b equals 2x plus 5. Group them. Yep. So I'll have ax plus bx. And what you could do now to make a shortcut is you could actually factor out the x right away here and go x times a plus b plus a minus 2b equals 2x plus 5. Okay. So you could, if you wanted to combine those steps, you could. A plus b equals what then? Okay. And a minus 2b equals 5. Now there is another way to solve this before you all go like typing into your calculator. Okay. Do you remember elimination and substitution? So let's do this. What happens to your a's? What do you get here? 3b equals what? Negative 3. So what does b equal? Negative 1. So then I can plug it in up here and get a plus negative 1 equals 2. What does a have to equal? 3. So that's another way you could solve. If you want to use an inverse matrix, that's fine. You can do that as well. You can also use elimination or substitution, which is something we learned years and years ago. So our partial fraction decomposition, I have 3 over, in this case, x minus 2, plus b, which is negative 1, over x plus 1. So see, that one went a little faster just because you were a little more familiar with the steps. Questions on the partial fraction decomposition? Okay, so this is what you need to do. On page 402, you have 4 problems to do. Okay, 1 through 4. And we have one more section to go, and we're done with the chapter. So.